Hey guys, welcome back. In our last lesson, we were finally able to start solving equations in the traditional way, with canceling things on one side, doing some things on the other, your traditional method for solving an equation. But our focus was on how and why. Well, now that we sort of have laid the groundwork for all the reasons how and why we solve an equation, we're just going to get into solving more complex equations. You won't need to write down all the properties today. You won't have to use structure to solve today. Today, we're just going to solve these equations like we normally would. Now, today we're going to look at what happens when you solve equations that have variables on both sides. And what do I mean by that? Take a look at this equation here. You should notice something different about it that we haven't seen so far. We have an equation in which you have x's on both sides. We have an x over here, and we have an x over here. How do we handle that? Well, some people believe you can combine like terms here, but you can't because there's an equal sign in between them. You can never combine two things across an equal sign. So this doesn't become 8x. You're not allowed to do that. So keep that one thing in mind, is that when you have variables on both sides, you can't combine variables on one side with one on another. You have to move it to the other side mathematically. Okay, and we're gonna learn about that today. In fact, I'll show you. We'll solve this same exact equation, and I'll show you multiple different ways to solve it. There's not just one. Okay, but our goal today will be this: get all of your variables on one side and get all of your numbers on the other. And again, it won't matter which side you bring them to, as long as you get your variables on one side of the equation and your numbers on the other, you'll be all set. Okay, here's that equation again that we just saw on the last screen. Let's go ahead and solve this thing. Now, the first thing we have to do is bring all of our variables to one side, all the variables to the other. I always bring over the variable first. Now, you can see with the note that I wrote down there that I'm going to bring the 3x over to the other side. Now, I do that by subtracting it from one side. Okay, that's the property, the inverse that's the inverse property and the property of equality. So with that being said, my goal right now is to bring this 3x over to this side here. So by subtracting 3x from both sides, what I've done is I've canceled it from here. So it's no longer on this side. I only have an 8 here. And I'm now bringing it over to the other side. Because remember, the property of equality says if I do it to one side, I have to do it to the other. So once I've done that, take a look at what I'm left with. I'm left with something that's just a simple two-step equation. I got the 2x because 5x minus 3x gave me 2x. I just brought down my negative 4, and I had a positive 8 from over here before. So that's how I ended up with this. And now I'll just solve this equation like I would have the past couple of days. Then we'll add 4 to both sides here. That'll give me 2x is equal to 12. And then I'll divide by 2, and I'll end up with x is equal to 6. Let me actually draw that in there. Divide by 2, x is equal to 6. Now, I have this big but because I just want you to know that that's not the only way we could have solved that equation. In fact, on the next screen, I'm going to show you a different way we could have solved this equation and still have gotten the right answer. Okay, so here's that same equation again. And often I'll get, well, what if I didn't bring the 3x over first and I did something else first? Is that wrong? Yeah, I don't want you to be afraid that there's only one way to do this. Watch. In fact, watch if I had brought the 4 over to this side first. Add 4, add 4. I get 5x is equal to 3x plus 12. I'd still bring the 3x now over to the other side because all the variables have to go on one side. All the numbers, or what we call the constants, have to go to the other. But as I work my way through this, I still eventually get to x is equal to 6. So that worked just as well. As long as I follow my properties that we've learned, we're still going to get an answer of x is equal to 6. Now let me erase this whole thing, because imagine that instead of bringing the 3x to the left side, I decided I'm going to bring my 5x over here. Would that be okay? Well, like I said before, as long as you follow your properties, you're still going to get the right answer. So this is a positive 5, so I'm going to subtract 5x to get rid of it. That cancels. I'm going to subtract 5x here. Now, I didn't mention this before, but the reason I'm subtracting it from the 3x is because they're like terms. Now, look at what I'm left with here. A negative 4. Be very careful. It's not a positive 4. 3x minus 5x is negative 2x. So you can sort of see the disadvantage of doing what I did is I'm going to have to deal with some negative numbers. Okay, 8 minus 8 cancels out. Subtract 8 on the other side. I end up with, that's a negative 12. Then divide by negative 2, divide by negative 2. And negative 12 divided by negative 2 is still 6. So I'm still ending up with x is equal to 6 anyway. But just a different approach. And I show this because I don't want you to feel like there's only one way that you have to do it and you have to be memorized, like this is what I got to do first. Now, my advice is typically bring my variables to one side first and then deal with the numbers to the other side after that, but it's completely up to you. All right, let's try one last one together, one that's got a little bit more complicated stuff to it, and then I'll let you go ahead and do your classwork. Okay, check this one out. Man, this combines a lot of the things that we've looked at over the past couple of days with what's new today. So some of the past days stuff is I see the distributive property happening over in the first part here. I see the going to have to simplify some like terms over here. And then we throw in today's stuff that there's variables on both sides. And now we got ourselves a pretty complicated equation. But let's just stick to the things that we've talked about. Remember, we said that if there is distributing in the problem, do that first. So let's distribute here. 3 times 4x is 12x. 3 times negative 5 is negative 15. On this side, let's simplify by combining some things that are alike. So we have an 8x and a positive 2x. Notice how I kept the sign with it. So that gives me 10x plus 13. All right, so I've already made the problem look a lot easier just by simplifying right off the bat. And now this looks a little bit more like what we were just dealing with a minute ago. Let's bring 10x to the other side. Now, you might be asking yourself, why did you choose to bring 10x over there? I looked at the two numbers, and what I tried to do was see which one, if I brought it to the other side, would keep the variable positive. That's all. Okay, now I'm adding 15 because that's a negative 15, so that'll cancel. 13 plus 15, I believe, is 28, and I'm almost done here. Divide by 2, multiplicative inverse, divide by 2, multiplication property of equality, and x is equal to 14. I'm done. Now again, it's not the only way you could have done this equation. I could have solved it a different way by bringing the 12x to the other side, or starting by subtracting 13, or a lot of different things I could do. But the reality is when you have variables on one side, you have to bring, or when you have variables on both sides, you need to bring the variable to one side and the numbers to the other. All right. Well, good luck working on this on your own, and we'll see you next time.